Hi, my name is Michael Posvon. This is my lab for oscillations video. Introduction. So the purpose of the lab is to compare real-world observations of a spring mass oscillating system to a computer-predicted system. So the system in our experiment was the mass, spring, and the Earth, and we used potential energy. Surroundings was nothing because only potential energy was used, and there was no work done by the surroundings. The real-world system, so in our real-world part of the experiment, was a video given and analyzed through Tracker, and this was the option one. And the computer program was used through GoScript. The physical principles used in this lab: Newton's second law in the form delta P over delta T, position and velocity update formula, and the energy principles in these two forms. So our tracker observations were made through this video, which I feel like a lot of people did. Press the middle and track and got data of our X and Y position for this oscillating spring. The initial conditions. Initial conditions using tracker were T equals 1.45 seconds. Then we solved for K, which we got around 6.87 seconds, and then solved for L naught using this equation and got 0.123. Modeling with GlowScript. So modeling with GlowScript, we got the data, the code shown on the screen, which basically just inputted the different equations into GlowScript. And the spring constant that we got from just calculating, or L naught that we got from just calculating it, gravity is constant close enough to Earth, but 9.8. And then we just put in our energy and position velocity update equations. So this is the graph that we got using that. This is there's no video here because it's not playing, but there's a graph we got using that GlowScript model. All right, other graphs. So graphs is the change in energy versus change in time. As you can see, the different energies kind of coincide, but always cancel each other out because the change in energy is zero because we are not adding anything to the system. So position versus time of our model graph with our next to our experiment was very closely aligned. So I think the model did quite a good job of tracking. And the only real thing is errors we'll talk about in a minute. And same thing with Y position for X and Y. So possible errors. Um, Really the only errors were rounding errors in our other glow script or our own calculations. And then tracker didn't exactly uh, work very well first for rounding errors with that and didn't kind of present exactly the center of mass, so we didn't get perfect data and real world errors. All right, what does it mean, part one? So the total change in energy is zero, so the energy principle is satisfied, as you can is demonstrated by this graph, where delta E remains constant, again, because there is no energy acting on from outside of the system, because the system is included. The system is the Earth, spring, and the weight, so it's all included. That's why we can use potential energy. All right, what does it mean, part two? All right, to estimate the oscillation period, I used X and Y position data from Tracker, as we just shown. Each For each direction, I identified one full oscillation cycle by measuring two consecutive points at the peaks of each graph. After analyzing the X position data, I estimated the period and got 1.56 and 1.67 for the Y position data. When comparing both estimates, the periods were very close together, which suggests the system is oscillating symmetrically in both directions. And small differences there can be really measurement errors, noise, or asymmetries in the system. Um, we we can kind of see from the video that it is not perfectly oscillating because if we got exactly the same, it'd be in a circle, but it's kind of an oblong oscillation. So it's not exactly perfect. That's why the numbers are slightly off, but there's also errors to be involved. All right. Thank you.